Okay, so we're gonna do the Roman numeral kata.
Yep. Specifically converting Arabic to Roman numerals as opposed to the other way or
Some other
Roman numeral calculator or something.
right. Okay, so I normally start this is with a 1.
The way I normally start this is with an empty string.
That's fair.
It's you've seen the video that Corey Haynes did a while back, right?
Probably.
Yeah, that's how he starts it. You do have to, like, technically, empty string didn't really exist, and 0 definitely didn't exist in Roman numerals, but
wait, so your input is a
your input number? Your input is a 0 and it returns an empty string. Doing it that way.
Okay. Okay. Wait, so your input is a string and your output is a string? Is that?
Oh, sorry. The input is an integer and the output is a string.
Okay. So you're inputting 0 and getting out empty string?
Yeah.
That's fine.
It gives you.
Let's write that test.
Okay. I'll write that test. Unless you want to write that test.
Sure. I'll write the test while you tell us why you like that test.
Okay. So I like that one because one, it's an easy place to start. It is a little bit of a stretch on Roman numerals because, like, 0 isn't really defined in Roman numerals, but it's going to an empty string, so you can kind of make an argument for it. The other thing is it gives you, if the way you implement your solution is to do it recursively, then it gives you a nice base case for your recursion. Oh, do you want me to generate that?
Yeah, it's giving me some quick fixes, but not the ones that I would have expected.
Huh.
Or maybe it was, and I just don't know what it's called. Okay.
Oh, and it should return a string instead of a bool.
It should return a string instead of bool. And V should be not V.
It should be not V. I usually call it Arabic.
That sounds good. Okay, well, it sounds like you already have an idea of where this could go in terms of recursive.
Yeah. So, I mean, after 0, I usually do the 1 case. The 1 returns I.
Okay. I'm gonna prematurely go potentially to a test case then.
I think that's a good option. It likes to do that.
Grab this, pull it down here. And I need a int
Arabic string, either Roman or expected or something.
Maze test is the name of the class.
Yeah, conversion tests. I don't know, converter tests.
Okay. I mean, I can just get it to pass and then we can finish that.
Oh, except it's return I. instead of 1.
Oh,
Oh,
this is true.
I think my conversion just got done.
Okay.
And I would vote we turn the 0 case into a test case also.
Yes. We now duplicate it. We can now get rid of this, and we are a little bit happier. Okay.
Okay, that's exciting.
Okay, so we're doing. You thinking 2?
So I think
What do you
it's
think?
interesting here to think about what the possible cases are.
Yeah.
Like 2 is an option, 5 is an option,
4 is an option.
4 is an option. Whenever I do this in a presentation, I always try to get people to suggest 4, and I'm like, no, that's too hard. I'm not going to do that. Do that for the whole time. It's entertaining. Yeah, 2, 4, 5. I usually go 5, but I don't know what happens if you do 2 first, how that impacts the code.
Interesting. I've usually done 2 next.
Oh, interesting.
So I'm more curious to take your route.
Oh, okay. let's do that then.
And then we can.
So I'll usually do, like, I'll do 5, and then I'll do 2 and combine the 1 and the 2 case, and then do 6 and combine the 5 and the 6 case, and then make the 1 and 2 case look like the 5 and 6 case or something like that.
Oh, let's see.
Okay.
Okay, so 5. You
I'll
just
pass, because of course it doesn't get. So we can do that.
Okay.
Do you want me to keep going, or do you want to type?
I can type if you want to tell me what to do.
Okay, so let's add the 2 case, because we could add like 10 and just add another if, but that's not super interesting.
Right.
So if we do 2, we could start with just adding another if.
Okay.
And then that should pass. And the way I do this is on 22, to make the duplication more obvious, on 22, I'll split the string to I plus I.
Okay.
And then you can turn the second I into a recursive call.
Oh, interesting. Okay.
And you can start by just passing it 1. And then depending on how much, well, to get it so that you, so you can actually collapse the 1 and the 2 case, instead of doing Arabic to Roman converter 1, you do Arabic to Roman converter Arabic -1. And that almost gets us there. It's interesting. You put the guard clause on when we went from 0 to 1. You added the guard clause on the 1. If you if you add it on the 0 on the empty string case, then you already have the base case for the recursion up at the top.
You can try that. So Arabic, or we could just
Fairweek equals 0.
0, right?
Yeah, return an empty string.
So we don't need these.
Right. And then I think you can get rid of the one. Oh, we can almost get rid of the one case. We have to change the condition on 23 to be greater than or equal to. Oh yeah, you could do that. It's less than 2.
Do
Yeah,
that,
yeah,
and then do that.
yeah.
Okay.
Yeah, that works. And then you can change, like you can, we could add 3 and change our condition on 21.
To be greater than 3 or less than or equal to 3. Right?
Yeah.
Okay.
And then we could do a similar kind of thing for 6.
Right. So I guess based off this pattern, right, we do 6 and that. We could do get it green with this. And then split it up.
Right.
And then I guess -5. And then this is
Equals 6. Yeah.
okay.
We can do that. And then
We just do 8.
yeah.
I mean, I don't know if it's that useful, but at least just 8.
Another way you can write the conditionals on 24 and 26 is saying, like on 24, you could say if Arabic is greater than or equal to 1, but then you also have to say and less than or equal to 5, which kind of makes it ugly. But then it makes it so that the value in the check and the value that you're subtracting in the recursion part are the same. It makes the fact that you're doing some sort of mapping from 1 to I and 5 to V explicit, but then this part, but then the conditions get uglier before you until you do some more significant refactoring. So yeah, I'm not sure. How does this compare so far to the way you typically do it?
Well, I don't typically do recursion, so this is new for me.
Okay.
So I'm curious where, I mean, I guess I can see where it's going to go. It's pretty, like at this point, we could add X and
yeah,
we're missing 4 and 9 still.
Right. So usually what I'll do is I'll add X, and you can do 11 and 13, 11 to 13 kinds of things if you want, and then I'll introduce some kind of mapping of, like 1 to I and 5 to V, have some sort of like a list of tuples or something, and then refactor to iterate through that. To iterate through that list of mappings and do the recursive call. That makes sense.
So you're looking at like this and this as your pair, right?
Yes.
So what about this?
That, like I said, if you write it differently, then you can say, Arabic is greater than or equal to 1 and Arabic is less than or equal to 5. And then the initial value that you're checking here matches this one here.
Okay.
But
so I'm thinking if we go from here, we can add 4,
okay.
right? Which then puts another if statement in there. Assuming, so I guess you can talk about this. I normally will add 4 as basically its own special case, right? So
yeah,
as opposed to trying to do some sort of subtractive
magic. Yeah.
Magic is right. Right. So if I don't know, you can almost do if it's equal to 4.
Yeah. And
really don't.
Yeah, you don't even need the recursive part.
I guess it's just how much you want to have this be the same to generalize it.
Right. The way I do it is refactor to a mapping. So I'll have 1 to I, 5 to V, 10 to X, and so on. And then I'll just add in the subtractive cases as entries in that mapping.
Right, which means that you'd still do the recursive call.
Yes. Yeah, you still do the recursive
call.
Which, like for 4, you don't need to, but then when you do it for
correct
40 or 90 or whatever.
Yeah.
That'll work.
Well, I'm wondering, so if we were to add that back, right? So we have our base case, and then we have a bunch of different things. Like, do you iterate over them? Oops.
That will be,
it should be minus 4.
Yeah. So you're asking about iterating over the mappings?
Yeah. So let's try that, because I'm kind of thinking that if we could put the
that check
as part of that mapping, that would be even better.
Yeah. So let me show you what I have done in the past.
Okay. Yeah. Let's look at the code, and then we can see where we can go.
Yeah. So you could do like a new list of int and string. And so then you'd have like 5 and V and 1 and I, and the order of course here of course is important. And then do actually usually do it with like a equals mappings dot the first one. This is always fun. X dot item 1, except I'll usually is less than or equal to the value that got passed in. Something like that. And then do mapping dot item 2, which we could change these names to something better. Minus mapping dot item 1. Do that, and then except I didn't put 4 in there, so
yeah, so we need 4.
Yeah, when I do it, I leave the subtractive cases until the very end as the big, like surprise.
Sorry to ruin your surprise.
Eh.
Okay, so if we do that, oh, so you look for just the next one.
Yeah.
Gotcha.
Yeah, so I said iterate over it. I guess that's not quite. I mean, this is a type of iteration, but probably not the kind you're
No, but yeah, okay. So you're looking until you find the one that is essentially matches that already.
Yeah. The doing it this way, it does kind of like the conditions that we had before, it just kind of ignores that, which is maybe too big of a step because I've done this before. I don't know. And I'm going towards the way that I am used to doing it, as opposed to the way that the code is, like the way we've written the code so far is driving us to go.
Right, because so let's say if we were to take this back out. Essentially, we're doing this the other way. So I'm just seeing how it would more map. So this would be if 5 is less than or equal to Arabic. Right?
Yeah.
Yes. Then also in here, if 4 is less than or equal to Arabic. Which, and then this is just switched around, right? Well, it's 1 is less than or equal to Arabic.
Yeah. Yeah, if you write it like that, then it makes the, mapping between 5 and V and 4 and IV and 1 and I nice and explicit. I don't know.
Yeah, because then you could say here, this is, well, again, just thinking about how to do it incrementally. Increment here would be, we'd then get, what be Roman and this be Arabic. I'm just gonna call it Arabic too. That's awful. But you can, and we'll just set that equal to mappings. Oh, well, I guess we can do
the first one where item 1 is, I guess it would have to be, you could explicitly do less than or equal to 5 here if you wanted to.
It's not being used, or do I have to say var?
You have to, yeah, that did work. Okay. I thought you were gonna have to put the types on Arabic too in Roman.
Oh, it's still not working though.
Oh, you need a semicolon at the end of 36. Maybe that's all. Oh yeah, looks like that's all.
Okay.
We could also on the mappings on 25, we could give the integer and string better names if you wanted.
Yeah, I don't know if I know how to do that
I
easily.
think you have to do it here. I think. I think you have to do that. And then I think you can change this too. Yeah. Like that.
Okay. And then at that point, then this is already essentially generalized.
Right.
We've now done the same thing we're doing here.
Right. But we did it in a more incremental process than what I did.
What's your better name for Arabic 2?
If you just name the tuple here.
Yeah, but we already have Arabic as our input.
But then can we do like
Oh.
Like that?
Yeah, okay.
That better or worse?
Well, it's better than Arabic 2. And I think it does explicitly keep that Arabic with the mapping as opposed to otherwise just having it be free floating out there. Huh. Okay. I like it. And I like the increments we discovered to get us there. It's a little bit.
Yeah. Those were increments that I don't like. When I do it in a presentation, I don't usually do that.
Yeah.
I haven't done that in the past. So I like that.
Yeah. One of the things that I have discovered by doing some of these things over and over and over again is that you can really dig in and find those little ways, little techniques to go, okay, well, here's where I kind of want to be here. How can I incrementally get there?
Yeah.
So yeah. Anything else?
No, I mean, at this point, it's just adding the extra test cases for like 10 and 50 and 100 and so on. And so the way I'll usually do it is I'll add, 10 and 50 or something like that. And then I'll add all the rest of the non-subtractive cases.
Sure.
So 100, 500, 1,000, and it then add to this mappings collection, and then I'll go and add the subtractive ones.
Yeah.
But now it's just adding tests for to force us to add things to the mappings collection.
Yeah. So where I usually end up is not recursive, but I mean, essentially, I think anytime you do this, you're going to need to end up with some sort of mappings, unless it's just all hard coded. But you just start at the top and you see, can I, like, is it bigger than this? If it is, like, you can, while it's still bigger than it, you just take it off and add that value on there.
Right.
And then it's just iterative. So I don't know. I'm gonna have to think about it. But I like this.
I'll have to do it the non-recursive way. I don't think I've done it that way before.
Okay.
The nice thing with this one is you can, like, if you go like this, if you're okay with that, and you're okay making this a class level variable, you can make it static read only if you want, and that sort of stuff.
Yeah.
Then the actual implementation is
3 lines.
3 lines, which is nice.
Yeah, and once we gave the tuple parts names, that made it a lot nicer. Although, again, we could have done projection out.
Yeah.
But I think I do like having them be explicitly still part of the tuple there on 33.
My favorite part is that you end up with fat arrows going both directions on that one. Not confusing at all.
Well, you have X goes to X dot Arabic is less than or equal to Arabic.
Yeah. Yeah. But it looks like, that you have two fat arrows. It's just
But
interesting.
It's like the X's versus the Arabics.
Yeah. It's just interesting syntactically.
Yeah.